Okay, so now let's talk about arccosine. When we're dealing with arccosine, by the definition, if we say y equals arccosine of some value x, x is the ratio whose cosine would the that would go with an angle whose cosine is y. There we go. Okay, so what does that mean? Well, of course, x, as before, is limited to being values between -1 and +1, and the y values this time are limited to being between 0 and pi. All right. So if somebody says, well, let's evaluate arc cosine of -1/2, well, that means that there's some angle y whose cosine would be -1/2. Now, on the interval between 0 and pi, we think what angle would do that? Well, it would have to be the kind of angle whose ratio of adjacent side to hypotenuse was equal to -1/2. So -1/2 over 1. Well, there you go. This looks pretty familiar. In fact, we might recognize this y value as 2 pi over 3. Now, if you don't recognize it, don't forget that it's the kind of right triangle that if the ratio were 1/2 to 1, we would have pi over 3 as a reference angle, but since we're in the second quadrant, we're going to take pi minus pi over 3 to get it. And that's going to give us that 2 pi over 3 as the standard position angle on the interval from 0 to 2 pi, whose cosine is -1/2. So that's our answer right there. All right, let's look at the arc cosine of 1. Arc cosine of 1, where do we get that? Well, now we have to remember, on the interval from 0 to pi, what angle is it whose cosine would be equal to 1? Well, that is actually right over here. At the point 1, 0, don't forget, if this were a unit circle, we would say at that point, then we're going to get, well, an x-coordinate of 1, a y-coordinate of 0 on that unit circle. We associated that with a cosine for the x-coordinate. And so in this case, it looks like we're going to get the angle 0 as well. And that is because on the interval that we're given here, the cosine of the angle 0 radians is equal to 1, the ratio 1. So that's what we're going to give as the solution here.